Next example, we want to find the derivative of 3x squared plus 5 over 2x minus 1, and we're going to use the quotient rule here. Quotient rule. So the quotient rule, depending on the type of notation you want to use, but let's call this f of x and g of x here. So the quotient rule is the derivative of the top times the original bottom minus the original top times the derivative of the bottom all over the bottom squared. Numerator over denominator, derivative of the numerator times the original denominator minus the numerator times the derivative of the denominator over the denominator squared. Another way of notating that. So let's go ahead and do that. So we're going to take the derivative of the top for our f prime of x. So the derivative of the top is going to be 6x, and then because 2 times 3 is 6, 2 minus 1 is 1, so just x, times, let me erase this g of x here so it doesn't get confusing, times the original bottom, which is just our g of x, so 2x minus 1, minus, and whenever you're subtracting off, you want to just get in the habit of putting brackets or parentheses around that second part, just in case we have some multiplying to do or some distributing to do. So you want to make sure you're subtracting off this entire statement here. This entire statement is being subtracted off. If you don't put parentheses, it's very easy to just write this as like minus x plus 3 when it should be minus x plus 3 like that, where we're subtracting off the x and the 3. So it's really easy to just make little mistakes like that. So where are we at? We want the original top. So 3x squared plus 5 times the derivative of the bottom. So that's going to be derivative of 2x minus 1 is just going to be 2. All over the bottom, 2x minus 1 squared. All right, let's keep going. So we have a couple things we need to do. We need to distribute this, we need to distribute this, and we need to make sure we're subtracting off all of this. So let's do a little bit of a 2-for-1. I'm going to do this step and this step. I'm not going to subtract off just yet. So I'm going to do 6x times 2x is going to be 6 times 2 is 12. X times x is x squared. 6x times negative 1 is going to be negative 6x minus, and then I'm going to put still this in brackets because all I'm doing here is just distributing the 2 first. So 2 times 3x squared is going to be 6x squared. 2 times 5 is 10. All over, and then we don't want to expand out 2x minus 1 squared. I don't want to expand that out, we'll just leave it alone. Most cases something might work out, or we just leave it as is and nothing really simplifies out, but just keep going. I'm going to subtract off. So I'll have 12x squared minus 6x minus 6x squared minus 10 all over 2x minus 1 squared. Next, I want to combine like terms, and I have some like terms here. So 12x squared minus 6x squared, those are like terms. So I'm going to get 6x squared minus 6x minus 10 all over 2x minus 1 squared. I want to show you here what happens from this point. So right now you're looking at this and you're like, all right, I don't know. Let me move me out of the way. Like, I don't know if I'm done. I don't know if I need to keep going because I have this 6x squared minus 6x minus 10. I could factor out a 2. So let me just show you what happens here. If I factor out a 2, I get 3x squared minus 3x minus 5 all over 2x minus 1 squared. So in this original form, without it factored, you may or may not know if that's going to factor or not. So like you might be able to just understand how the numbers are going to work and know, like, all right, I don't think that's going to factor. But if you even factor out a 2 here, and then you have 3x squared minus 3x minus 5, and you try to factor that using AC method, look what happens. So if we try to use AC method, we want two numbers that multiply to a negative 15 and add up to a negative 3. So if you take this extra 15, 20 seconds and you just think, all right, I need two numbers that multiply to 15, add up to a negative 3. So negative 15 and 3. So I could try like negative 5 and 3. Negative 5 times 3 is negative 15, but negative 5 plus 3 is a negative 2. So that doesn't work. And then 3 and 5, not going to work. 15 and 1, 1 and 15, not going to work. So then, oh, okay, that's not going to factor. So then this would be the simplified version of this, because sometimes, the only reason I'm checking that is because sometimes this might factor and give us a factor of 2x minus 1. So then that would be able to simplify with the 2x minus 1 squared. Because we have two 2x minus 1s. 2x minus 1 squared is 2x minus 1 times 2x minus 1. So we have two factors of 2x minus 1. So if we got a 2x minus 1 on the top, one of those would cancel out. That's why you always want to check. Like, you don't want to just do the process, simplify, then be like, all right, here we go, done, moving on. You want to just make sure nothing can factor, because we do want to simplify this as far as possible. But in this case, it doesn't. We would factor out that 2, nothing would happen, so we'd be fine. So that would be the answer to the derivative of that function using the quotient rule.